Alright, we live. Saving on, we live, man. Alright. We're graphing the equation of a line today. This may seem like a one-off because yesterday we started transformations and I taught you how to do translation. I don't know if I mentioned it in this class yesterday, but I mentioned it yesterday. The kids, they were like, oh, translations is easy. I said, yeah, the hardest one in this unit is reflections. The reason it's the hardest one is because of this situation right here. We're not even doing reflections today. I just have to prep y'all to do reflections. To do a reflection on a graph, the first thing you have to put in is a line of reflection. And they'll tell you what the line is in slope-intercept form or whatever form they give it to you. They'll give you the equation of a line, and they'll say reflect this image over that line. But if you don't know how to graph a line, then you ain't going to be able to reflect no image for us. So we got to make sure today that y'all know how to graph lines. So honestly, this isn't even a geometry skill. This is an algebra skill, but we don't want to assume that everybody in here is 100% on graphing lines. So we're going to spend one day just graphing lines, and then we'll go to, next time we see each other, we'll start reflecting over the lines. But we got to make sure y'all know how to graph lines today. So that's where we at with it. Another thing too, we sit there each year and we teach y'all 3 different methods to graph a line, but it's really a waste of time. The only method y'all gonna use to graph a line in here for us is slope-intercept form. So me and another teacher was talking about it. We should have just let all these examples on the front just be slope-intercept form examples. So that's what I'm gonna do. This first one is telling us to do a T-chart with X and Y inputs. That's a waste of time. We're going to put this equation in slope-intercept form, and then we're going to graph. We're not going to do the T-chart method. We're not going to do, what's this other method? We're not going to do this one at the bottom, this X and Y intercepts method. We're going to do slope-intercept form, do that, and run with it. All right. So the first one, this equation, and they put it in slope-intercept form. Subtract the x. Y'all should know how to do all this. F of this ain't nothing new. Y equals
3 over 2x plus 8.
Thank you. 3 over 2x. You said, oh yeah, I forgot that other negative 2. Thank you. Plus 7. Correct. Don't forget you dividing by negative 2, so you zoom in. Negative divided by negative turns positive here. Negative divided by negative, that turned positive as well. Alright. Then from there we in slope-intercept form, so now we should know our slope and our intercept, which is what's our slope? 3 over 2. Y-intercept? 7. Oh, this is a good one to start with. This is where you have issue. I'm glad we're doing this one first. So, to graph a line, you start by putting your y-intercept on the graph. My y-intercept is at 7, which is all the way up here at the top. That's what it says my line is going to cross the y-axis. Way up there. And then my issue after that is my slope is 3 over 2, so that's rise over run. That's going up 3 and over 2. If I do that, then I'm gonna be off of the graph. If you run into this situation, and it's a good one to start with, because you will run into this situation from time to time where your slope is off of the graph. If that's the case, then you have to go backwards. To go backwards though, you're going to take your slope, whatever it is, and you're gonna turn it double negative. So instead of using 3 over 2, I'm gonna use m equals negative 3 over negative 2. I'm gonna use a double negative slope, and so I'm gonna go back that distance. So what is it, rise over run? And so instead of rise over run, we're gonna fall and not run but backtrack, I guess. So I'm gonna go down 3, 1, 2, 3, and then I'm gonna go to the left 2 since it's a negative 2. Back 1, 2. That'll give me my next point on the line. And then you can do it again if you want. Down 1, 2, 3, back 1, 2. This is only on the problem where you are going to end up off the graph with your next point. And if you look, me doing that, I put 2 other points on here. Say that last point I created right here, that one I created. If I count my slope from there, it's going to be what I wanted it to be, which was 3 over 2. Up 1, 2, 3. To the right 1, 2. So that's my positive slope, 3 over 2. I just had to count backwards to get it. I had to go down 3 and back 2 just to get that to happen for me on this first one. I think y'all can understand that. Y'all okay with that? Anybody not okay? I can say it slower. It's gonna be the same thing though. Okay. Like I said, I usually like to get 3 points on there so I can draw a line. And then I'm going to draw my line through my stuff. It's like I said, it's 1 out of every maybe 5 or 6 times you may get a situation like this. Don't happen often, but just if you understand that if you run into a situation where you're gonna run off a graph, that's what you have to do, backtrack. All right. Next one, we're gonna do slope intercept form on this one. This one we were supposed to do slope intercept form on, but minus 2x minus 2x cancels, y equals negative 2x plus 4. Jorge, give me my slope and my intercept. Negative 2 and b equals 4. I'm going to show y'all something else when y'all get to y'all work. Oh. Alright. So on my graph, first thing I'm putting on is my b, which is at 4. Oh, that's the other thing too. My bad. Slope always needs to be what? A fraction. So instead of negative 2, we should have said what? Negative 2 over 1. So for slope, you got to have a rise and a run. So when you pull that whole number out, make sure you turn it into a fraction. Alright. So I'm at 4 on the graph for my intercept. After that, I count my slope. My slope is negative 2 over 1. So am I rising or am I falling first? This is really a fall. You're not rising if you got negative. So it's a fall of negative 2, down 1, 2, and then I'm running to the right, 1. And then down 1, 2, run to the right. We always run into the right except for a situation like we had at the top up there where we couldn't run because we were off the graph. That's where you had to go double negative and go backwards. But in any other situation, you always run to the right. Down 1, 2, run to the right. Just put 4 on there. Put however many you want on there. last one we're doing slope intercept form too. This is gonna be interesting.
It's actually not that bad.
It ain't. It does it fit on the graph?
Yeah, it's basically there.
Okay.
It's 11/4x-6.
Okay. Also, it's at -6, so yeah, to stay on. Good. Plus 24 divided by -4 divided by -4 divided by -4 cancels. Y equals positive 11/4x minus 6, like he said. So Tim, M and B.
M is 11/4, and then B is -6.
Alright. So we put our intercept on first, going to -6 on the y-intercept, on the y-axis. And then from there we count our slope of 11/4. Probably only going to be able to put 1 point on, but that's fine. You only need 2 points to create a line, remember that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 over 1, 2, 3, 4.
They all stay on the graph.
Yeah. I'm going to let y'all do 1 and 2 on the back. I'm going to come back. I mean, not 1 and 2. Oh, yeah, it is 1 and 2. I forget about this. I forget about these little edits that need to be made. Do the 2 at the top. We numbered this wrong on the back, obviously. This probably should be number 4 the way it's numbered. This one up here. I always forget about this back. So do 1 and what's supposed to be number 4, those 2 at the top. I'm going to come back and do these other ones with you. Let me pause this. I guess I said this out on camera. The most important ones you're going to have on the sheet are number 2, or the real number 2, number 3, and number 5. These are mainly how you're going to see equations of lines or reflections being asked for you to graph. So if they want you to reflect over a line, it'll probably be a y equals line or an x equals line. You just got to know how to put it on the graph correctly. And some of y'all get confused with the y equals or x equals line. Y'all put it on the wrong spot. So, what?
Since it's y equals 4, wouldn't the y-intercept be 0?
No, he right. The y-intercept is 0. No, it's not all that. Oh, no, you overthinking this. No. No, the y-intercept ain't 0. I'm lying. Dang, you made me say that on video. No, that's wrong. The x-intercept is 0. So, the main thing you need to do, when they say y equals a number, go on the y-axis and put a point at that number. So let's say y equals 4. I'm going to put a point here. But this is where kids get confused at. It's y equals 4. They think, oh, so this is my line down here. No, the y-axis is not your line. Y equals 4, that means your line is going across 4. It's a horizontal line. I think I made them write this in on their notes last year. I should have put my old notes out. Oh, wait a minute. Right here. Out to the side. Make a note for yourself. Y equals a number. Let's just put yeah. I don't know how I'm gonna write this. Y equals a number. Any number is a horizontal line. So if you put y equals a number, that's a horizontal line on your graph. In reverse of that, x equals a number is x equals -3. So on my x-axis, I'm going to -3. X equals a number is a vertical line. So on my x-axis at -3, and then I'm going to do a vertical line here. Making another note. X equals a number, let's abbreviate that, is a vertical line. These are the main ones. I need y'all know how to draw y equals and x equals, and they're the easiest ones to do.
If you have an x equals like that, what would be your b?
Say it again.
If you have an x,
You don't have a b,
there would be one.
because the line doesn't hit the y-intercept at all.
What if it's overlapping the y-intercept?
Huh?
What if it's overlapping the y-intercept?
If it's on the y-intercept,
Yeah.
then they're gonna call it. They're either gonna say reflect over the y-axis, or they do this: x equals 0.
Yeah, that's what it is. It's x equals 0.
Yeah.
'Cause this is
But x equals 0 is the same thing as saying the y-axis. So that's what it'll get you. If you look at number 5, that's what I'm about to talk about. Number 5 says y equals 0. What's that?
it would be a horizontal line on the y-axis or the x-axis.
No, exactly. So anytime they tell you y equals 0, they're talking about the x-axis, because it's y equals 0. So you stay at 0 right here, but then it's a horizontal line, so it's on the x-axis. So they could have just told you to reflect over the x-axis, but they said y equals 0 instead.
Number 8 on the homework is x equals 0. It's asking for b.
There is no b. Don't put anything. The b ain't 0. There's no b. The line never touches the y-axis, so.
Well, it's overlapping the y-axis.
Huh?
It's overlapping the y-axis.
Oh, you know what that is? That's what's it called? I think it's all real numbers. Because like any number, because it hits every point on that axis, so it's like all real numbers. That's the answer.
Is that you're going to write that?
Yeah, I'm serious. For that one, that should be. So if it's like you say, if it's on the y-axis, the whole line, any point on that axis will be intercept, right? Because it intercepts all of them. I think it's all real numbers. Yeah, it's all good. I mean, this last one, y'all should know how to graph. It's already in slope intercept form. I don't even know why we made that the last problem. That's easy. Y'all should just graph that real quick. And then, yeah, that's it for me. Next thing we slide into is our airplane activity.